Hello, this is a tutorial video showing how to use the bioprinter. At the end of this video, you will be able to print, to control the bioprinter, and also to design a simple model of a scaffold by yourself. So let's start it.
What to do if you hear this noise? Let's understand the buttons. The left red button is an emergency button. You can press it if you need the bioprinter stops what it is doing. The three lights mean green, the bioprinter is ready to work; yellow, the bioprinter is working, printing right now; and red, the bioprinter is not ready to work. Every time you are turning on the bioprinter, the red light will be on. To make it become green, you just need to press the reset button. That key shows the two velocities the bioprinter can operate. You can choose the velocity by setting the key in the position you want the velocity to be. In safe mode, every command will happen extremely slowly. In normal mode, every command will happen quickly. Double-click on 3D Discovery icon and wait for it to open. It will show up a small green box saying it is in standby mode. Then, give a double-click on the minimized 3D Discovery icon. If this message shows up, it means you forgot to press the reset button before opening the system. If you pressed the button and the message is still there, you just need to review the steps the message asks you and you will solve your problem. This is what the software looks like. The first button is to set both printheads and platform to the initial position. The second button will bring just the platform closer to you. The third button is not really useful, but just for you to know, it moves platform and printheads to the most centered position.
Here we are going to fill the syringe with Nivea cream. We are going to use this syringe to fill the real syringe, which is this one. You can see it wasn't enough, so we are going to fill a little bit more. That's it.
This is a plastic top to be used at the end of the syringe. Use the screwdriver to push the plastic top a little bit, because we will need some space for the pressure plug-in. Attach the needle to the syringe. Place the syringe in the space of the printhead 1. Turn the black valve clockwise. It will stop the syringe from moving. Then, connect the pressure plug-in and turn it clockwise.
So we are going to fill it with water, and in case it was real cells, we would need to use a stopper here.
Let's put the plastic top. Use the screwdriver to push the plastic top. Place the syringe on that space on printhead 2. Place the needle adapter into the bottom. Place the needle into the adapter. Twist the needle counterclockwise. Connect the pressure plug-in and turn it clockwise. Use the screwdriver to tighten the screw. It is ready. You want to know if everything is okay with the needle, or if everything is okay with the material inside of the needle before you print something. This test is probably the only way to hurt yourself using the bioprinter, so pay attention. When you select the printhead one, look what happens. So, you don't want to have your hand under the needle during this moment. Be careful. Next step, you click on the button with the shape of a drop of water. If the material is okay and the needle is clean, it will start dispensing the material. The dispensing needs to be in a continuous line. If it is not, either the needle is not clean or the material is old. To stop, click on the drop water shaped button on the right. Now let's try the dispensing on printhead 2. Click on pH2. Click on the drop of water shaped button. Here we are dispensing colored water. Since the dispensing is divided, it means the needle is not clean. Clean the needle and try it again. Dispensing needs to be like this. To calibrate the needle, you will first choose the needle you want to calibrate by clicking on it. Then, click on NLM button. If nothing happens, it means you have your key set on safe mode. Go ahead and press any button on your keyboard, such as spacebar. This action will stop the bioprinter. Then, change the position of your key to normal mode and click on NLM button. It will start the calibration. After calibrating the first needle, go ahead and calibrate the second. Same steps. Select the needle you want to calibrate and click on NLM button. You need to calibrate the needle every time you turn the bioprinter on or when you move the syringe for any reason. Use 3 slides to cover the surface area shown by the red box. Align the edges of the slides to the appropriate holes. Then, we will push the white valve clockwise by 180 degrees. It will activate the vacuum through the holes to keep the slides in the right position during a print. If you don't know where the vacuum valve is, it is positioned on the right side of the bioprinter. After activating the vacuum, the slides don't move. There are 4 pressure valves on the bioprinter, each one connected to one printhead. To turn the pressure on, you just need to press this button on the software. It will activate the pressure of all the printheads. All the printheads will have the same pressure you set on the last time. You can change the pressure manually if you want to increase or decrease it. We will talk more about it later. To turn the pressure off, just press this button. Click on File, then click on Open File, select the file you are going to print and click on Open. Then, click on the button Run Program. The printing will start. If you need to stop the bioprinter for any reason, just press any keyboard button. Here you can see what a print looks like. The software we are going to use is the BioCAD. You can design using lines and shapes and create the G-code file, which is the code the bioprinter can read. And G-code file is nothing else than a text file with the extension ISO. Give a double click on BioCAD to open it. The main commands we are going to use are the new layer and new level. So let's start making the shape we want our scaffold. Click on circle and make a circle. It doesn't matter the size because we will define right now. Here on center, we are going to put 0, 0. And then the circle will be in the center of this page. We want to make sure it is on the center. Let's put 8 on radius, which is the measurement on the bioprinter's manual. So right now we already have a circle. Let's click on new layer and we will define the pattern to fill. So click on filling automatically and choose horizontal. Click on the border of the circle. Go ahead and click on new layer, then click on filling automatically and choose vertical. Click on the border of the scaffold. That's it. Now we have these little holes or pores and we have a structure of a scaffold. Now we will define the material and the printhead we want the bioprinter to use in each layer. Click on layer 1, then click on material. We will have a list of the materials and printheads available. Choose a printhead and material. Then go ahead and click on layer 2, define the material you want, then do the same on layer 3. The internal diameter of the needle in printhead 1 is bigger than the internal diameter of the needle in printhead 2. You choose the printhead depending on the material you will use to print. For materials with a higher viscosity, such as Nivea cream, Vaseline, or silicone, needle 1. For materials such as water, cells, or gel, needle 2. If you don't find the material you will use, you can add it by clicking on Tool and Materials. Then click on Add. Give a name to your material. On the second column, you define which needle will dispense it. On block, set it to 1. On feed rate, it is up to you. I will use 6. On thickness, you will set the thickness of the needle you are using. Flag pressure and click on OK. It is saved now. When you select this new material, it will always set the feed rate defined before, which in this case was 6, but you can change it right here if you want. We will talk more about how to define feed rates soon, don't worry. Now, we are going to define what the bioprinter will print first and in which order. To do it, you click on the layer you want to print first and drag it into the lower white box. So, I will select here the layer 1 and drag it into the box. It means the bioprinter will print the circle in the beginning. Now, I will click on the layer 2 and drag it. The process will be the same. The bioprinter will print the circle and fill the circle in the same level. For the layer 3, we will create a new level, clicking on the button New Level. Then, click on layer 3, keep the click and drag it into this new level on the box. When we click on layer 1, 2, or 3, we have access to the feed rate. Feed rate is what defines the velocity the bioprinter will print. I will change from 3 to 6 just to be faster. You need to change the feed rate in each layer. To finish the scaffold, click on Group 1. Here, we will define what is the initial and final height the bioprinter will print. On building height, we will define how tall the print will be. The bioprinter will repeat all the layers you created until achieve this height. On initial height, we keep 0 since we are using just a glass slide. If you are using something somewhat thicker than that, you will need to put here its measurement. Really important, every measurement is in millimeters. Next step, save the file. After saving it, you just need to click on that green triangle to generate the G code. Both files will be at the place you saved it. It is ready to be printed. Here, we have 4 different examples of pressure using the same file. I used just the printhead one, which is to print soft solid materials. The feed rate of this file was 3. So, on the first slide, I set the pressure 6. You can see it is too messy and there is no space between the lines. It means the pressure is too high for this feed rate. On the second slide, I set the pressure 5. You can see the print is linear and consistent, even though I still don't have space between lines. The third slide, I set pressure 4. This is the perfect pressure for this feed rate using this material, which was Nivea cream. The lines are with space and it has a perfect shape of a scaffold. The last slide, I set pressure 3. You can see that on the second layer it is failing. It is a sign the pressure is very low. We already know that feed rate controls the velocity the bioprinter will print, but when we change the feed rate, we will have a different result. Here I set the same pressure 4 to both prints, and I changed just the feed rate. You can notice we have a bigger line on the slide on the left, which the feed rate was 4. Since the needle will move slowly, we will have more deposit of the material. So, if this amount of material is too much for what you need, you will need to change the pressure to dispense less material. Because of this, we can say pressure and feed rate are always correlated. If you change one, you will need to change the next one. Unfortunately, we don't have an easy way to find out the perfect values of feed rate and pressure. You just get this knowledge by testing it. If we want to print a scaffold and fill it with the cells at the same print, we can design it on BioCAD. Let's open the same file on BioCAD. Click on New Layer. Then, click on the button Zoom and Area. Click outside of the scaffold and drag your click around the scaffold. It will zoom it. Now, click on the button Point. Then, start clicking in each space you want to fill with the cells. Keep in mind the bioprinter will fill in the order you are clicking, since each point has a number. When you finish it, click on the layer we created right now and select the material and needle you want the bioprinter to use on it. Here you can also change the feed rate if you want it faster. Now, click on New Level, then click on the layer we created right now and drag it into this new level. Now the scaffold is ready, you just need to save the file as we did before. Then, click on the green triangle to generate the G-code. Finally, it is ready to be printed. Converter is a software to convert 3D images to ISO file. These images need to be in STL or AMF extension. We can get these images on the internet, download it, and then convert it to print without needing to draw everything like on BioCAD. First of all, open the file you want to convert on Converter. When you click on the platform and drag it, you can move it in 3D directions in order to see the image from all the angles. You can change the position of the image in so many different ways using those colored buttons. If you want to change anything, go ahead and use it. If you don't want to change anything on the image or you finish changing it, you just need to click on the button Center. It will make sure the image will be at the center during a print. Then, click on Move to Platform. It will make sure the image is touching the platform. Click on Save to save the file. Then, click on Export Process Protocol. Give a name and save it. It will create an ISO file of this image. It is ready to be printed. Shut down the computer and then press the buttons 3, 2, and 1. If you already finished printing it, take the needles off the syringe and clean it using ethanol, isopropyl, or acetone. Doing it immediately will avoid formation of crystals through the needle. To change the file you want to print, click on the white box. Press Ctrl A, press Delete, and then click on Refresh button. Then go ahead and open the new file. It will save your time from closing and opening the software again.